Hello everyone, Assalamu alaikum. This is me Faraz Gurban Rajpar, and in this video lecture I am going to start the video lecture of organic chemistry. So in this video lecture I will discuss about the basics of chemical reaction. Our focus will be on the organic chemical reactions. So let's check out what is basically the chemical reaction is. A chemical reaction is basically a phenomena or process in which the two reactant molecules are reacted and get converted into the product. So the two type of reactant molecule that are involved in the chemical reaction are the substrate molecule, and the second one is the reagent molecule. So basically in this chemical transformation, these reactant molecule can be partially or completely transformed into the desired product. So product are basically the resultant of the chemical reaction. So let's take the example. For example, the A and B are going to react, and after the chemical reaction they will get converted into the C. C is said to be the product of both of these A and B. So one of the reactant is A and other is B, and the reactant which is being attacked by the other type of reactant is known as the substrate molecule. Means substrate is that reactant molecule which is being attacked by other chemical species to initiate the chemical reaction, and the reactant molecule which attacks the substrate to cause any chemical change in order to get converted into the desired product is known as the reagent molecule. So basically substrate and reagent are the two type of reactant molecule that are involved in the chemical reaction, and product which is formed by the interaction of both of the substrate and the reagent molecule is known as the product. So as our focus is on the organic reactions, so organic reaction is basically those type of reaction that are occurring in the organic molecule, means those which basically contain the chemical skeleton of carbon and hydrogen, whether they are aromatic or aliphatic or alicyclic. And in those organic reaction, our reagent molecule may be organic or inorganic. Reagent is that is going to attack our substrate molecule, but our substrate must be the organic species, because we are going to cause the organic chemical reaction, and for that our substrate molecule must be organic, and in reagent molecule can be organic or as well as inorganic. This chemical transformation of the reactants into the product can be a multi-step reaction, and at the same time it can occur in the single step reaction, but most of the time a chemical reaction is occur in the multi-step reaction, which involve the formation of different intermediate subproducts or the other intermediate species, some of which can be reactive and some of which can be stable. So all those species that are going to form during the conversion of reactant into the product are known as the intermediate species. So number of species that are formed and destroyed. Means, for example, a chemical reaction is occurring in the 4 different steps. And after first step, we will have one of the product that is not the actual product, but it is acting as the chemical species, that is the intermediate. Clear? And now in the third step, this product of second step or first step is again going to convert it into the other chemical species. So at this time this is going to be destroyed. It is now again chemically modified to get converted into the next phase. So these molecules are the intermediate. A reaction mechanism is basically a series-wise, step-wise actual process of chemical transformation. Means it describes the real mechanism by which a reactant molecule react and get converted into the product. By understanding the reaction mechanism, we may observe that how the movement of electron is occurring between the two chemical species, which type of bonds are being formed or being broken among the two chemical species. Clear? So basically we know all of this by the reaction mechanism, and by the reaction mechanism we can also get the idea about the different type of intermediate and the transition states of a chemical reaction. So basically reaction mechanism is the summary picture of our chemical reaction, means by which we may have the idea about all the chemical changes that are occurring in that type of particular chemical reaction. Now let's discuss some of the most important type of the reagent molecule. Type of reagent molecule means the reagent, we have discussed that it is that type of molecule which is going to attack our substrate in order to cause the chemical reaction. Clear? That attack to substrate to form the product. So basically there are main two type of reagent molecule. One is the electrophile, second is the nucleophile. Electrophile in general are those chemical species that themselves are electron deficient, means they do not have complete uptake of electron, they are electron deficient. So that's why they are going to attract the electron rich species, means they need those chemical species which have the extra pair of electron or which are rich in electron in order to complete their octet. So electrophile, that's why are known as the electron loving. Electro is for electron and phile is for loving. So as they are electron loving, they requires the electron to complete octet. They are gaining electron, that's why they have the positive charge. So they are the electron loving reagent molecule, and they participate in chemical reaction. How are they going to participate? By gaining the electron, and they are attacking those reaction center which are richer in electron, and that type of chemical species is a nucleophile. So basically in a chemical reaction, electrophile species is attacking the nucleophile center. So we have studied the different theories about acids and base. One of the well-known theories given by the Lewis scientist. So for that he given the concept for Lewis acid are those chemical species which are accepting the electron, and as in case of electrophile are also doing same. They are requiring electron, they are gaining electron, they are accepting electron. So that's why electrophile can be known as the Lewis acids. So now let's check out the different examples of electrophile depending on whether they are positively charged or they are the neutral. Most of electrophile are positively charged, and they require the electron in order to complete their octet. So the example of positive electrophile are H positive ion, nitro positive ion, ammonium positive, hydronium ion, and the other ions. The example of neutral electrophile means they are neutral electron deficiency species, means they do not have any type of charge, electrical charge, they are neutral. So but at the same time they have an atom with an incomplete octet, means they again require the electron to complete their octet. The example are BF3, LCl3, ZnCl2, FeCl2. So these all are example of neutral electrophile, as they are again gaining the electron in order to complete their octet. So that's why they can also be termed as Lewis acids, because they are also the electrophiles. The second type of chemical reagent is the nucleophile. Nucleophile means nucleus loving. Nucleophile is that chemical species that donate the pair of electron to an electrophile to form a chemical bond are to cause a chemical reaction to form a product. So nucleophile themselves are the electron-rich species. As they are electron-richer species, so that's why they have affinity to donate the extra pair of electron. So all those molecules are ion that have a free pair of electron or extra pair of electron, or that have at least one type of pi bond. They can be act as the nucleophile, and as they are going to donate the electron, so we can also use the Lewis basis concept over here. So that's why they can be termed as the Lewis bases, as they are going to donate the electron, and because Lewis bases are those which have affinity to donate the electron. So on that basis, on their affinity to donate the electron, they may have the negative charge. So these are the electron richer species carrying a negative charge, which attracts and the electron deficient side, that is the electrophile. The example are hydroxyl, cyanide, chloride, and the RC double bond O that can be occur in the carboxylic acid esters. The neutral nucleophile are the neutral electron-rich species. They contain the non-bonded pair of electron, like the H2O, RNH2, NH3, NH3, and the RSH, that is the sulfone group. So this was the basic about the reagent. Now let's discuss about the different type of chemical reactions that are going to take place in the organic molecule. So these are basically the type of organic reaction. Over here I am only giving the overview of the different type of organic chemical reaction. So first of all, let's discuss about the substitution reaction. Substitution reaction, as the name is indicating, means something is going to be substituted during the chemical reaction, and as something is going to be substituted means it must be going to occur in the reactant molecule. So substitution reaction is basically any type of organic chemical reaction in which an atom or group of atom in a molecule is being substituted or replaced by the other atom. So that is reaction is known as the substitution reaction. The atom or group of atom that is going to be substituted in our substrate molecule during the substitution reaction is known as the substituent. So there are the different type of substitution reaction, and on that basis they can also be termed as the single displacement reaction, because one of the chemical species or the group of atom is going to be substituted, is going to be displaced, and it mostly occur in the single step. The main type of substitution reaction that occurs in the organic compound are the electrophilic substitution reaction, nucleophilic substitution reaction, or the free radical substitution reaction. And again, this depends on the type of chemical reagent involved, whether it is the electrophile, whether it is nucleophile, or whether they are the free radical. So now let's discuss the example of the substitution reaction. One of the well-known example is occurring in the aromatic compound, that is the benzene. The nitration of benzene will form the product nitrobenzene. So in this, basically the nitro group is being substituted at this position in the benzene ring, so that's why nitrobenzene is formed. So nitration is nothing but is the substitution reaction of benzene with the nitro group, in which the one of the hydrogen in the benzene ring is replaced by the nitro. The other example of the substitution reaction is the halogenation. Halogenation is the substitution of one of the aromatic site of the benzene with the any type of halogen molecule, like it can be the chlorine, it can be the bromine, depending on the type of halogen, and it is mostly occur in the presence of the catalyst like the FeCl3, FeBl3. So these are the Friedel-Crafts acylation reaction. So the example is the chlorobenzene, and the catalyst required for the nitration of benzene is the sulfuric acid. There is another type of chemical reaction, that is the substitution reaction, is a sulfonation of benzene that occurs in the presence of the sulfuric acid. In this sulfonic acid group is being substituted at this site. Substitution reaction can also occur in the carboxylic acid. For example, when the carboxylic acids are reacted with the alcohol, this is the carboxylic acid, that is the acetic acid, and when it is going to reacted with the ethanol, then the product will be formed is the ester. So substitution reaction of carboxylic acid with the alcohol will form the ester as a result. And there, if we will observe this reaction in the lab, the fruity smell will be formed in our product. So in this reaction, basically at this site you may observe the substitution of this ethane molecule is occurring from the ethanol. So in the product you may observe this is the again methyl C double bond O, this type of functional group C double bond O, and the alkyl radical on both sides of this is representing what the formation of ester, and water is removed in the reaction. Again, if we are going to react the carboxylic acid with the primary amine, they will again form the amide. So carboxylic acid can undergo through the substitution reaction, and as a result they can form the esters and amide depending on the type of reagent molecule. For example, in case of alcohol reagent molecule, carboxylic acid can be converted into the ester, and in case of the amine as a reagent molecule, they are going to convert into the amide. The second type of organic chemical reaction is the addition reaction. Addition reaction is that type of reaction in which molecule is being added across the different multiple bonds to form the product. For example, the addition reaction mostly occur in the multiple bond organic molecule, like it can occur in the alkene and alkyne. Alkene which have the double bond, alkyne are those having the triple bond. Let's take the example of alkene, that is the ethene. Hydrogenation is one of the addition reaction example. Hydrogenation means addition of hydrogen, means now in this saturation is being occurred. So example is the hydrogenation of ethene molecule. It will occur obviously in the presence of hydrogen, and platinum is used as a catalyst. So during this reaction, this hydrogen will cause a saturation of this double bond, and now this double bond will get converted into the single bond because saturation is occurring, and now it is going to convert it into the alkane molecule. The second type of addition reaction is the hydration reaction, that is the addition of water molecule. A hydration reaction example is the reaction of ethene, or that can be also named as the ethylene, that is when two carbon are being bonded together by the double bond. When it is going to react with the water molecule in presence of H3PO4 that is used as a catalyst at the 250 degree centigrade, then this will be converted into the ethanol molecule. This is occurring as a result of the hydration reaction. So basically what is causing the hydration? Addition of water molecule means 2H are being transformed and one of the oxygen of this water. So this will get converted into the ethanol, that is the product of the hydration of ethene. Another type of example is the halogenation. Halogenation is introduction of the chlorine in the chemical structure of the double bonded, that is ethene. So when ethene undergo the halogenation reaction, then it will form the product that will have the chlorine molecule in its structure. So 1,2-dichloroethane is formed. How this is formed? At the same time you may observe this is saturation of this double bond is being occurred. So as a result, the 1,2-dichloroethane is being formed. So in the product you may observe this ethene is being converted into the ethane. The next type of reaction is the hydrohalogenation, means in that is occurring in the presence of hydrogen bromide, and in this the propene is being converted into the 2-bromopropane, because in this you may observe that bromine atom is also being added and the hydrogen is also added. Or the other type of product that is not usually observed is the 1-bromopropane. So the major product that is occurring by the hydrohalogenation reaction for reacting the propene into hydrogen bromide is the 2-bromopropane. The third type of chemical reaction that occurring in the organic molecule is the elimination reaction. Elimination reaction are those type of reaction which involve the removal of atom or group of atom from the adjacent molecule in the substrate by reaction with the reagent molecule. So as it is causing the removal of atom or group of atom, so it can be termed as the reverse of one of the reactions that we have already discussed, that is the addition reaction, in which atom or group of atom are being added. So in this reaction usually the 2 sigma bonds are lost and a new pi bond are formed. This is again the reverse phenomena of the addition reaction, in which the pi bond are getting converted into the sigma bond, but over here in elimination reaction sigma bond are lost and a new pi bond is formed and the saturated compound become unsaturated. This is the opposite in case of the addition reaction, where unsaturated compound are becoming saturated. An elimination reaction can occur in the 1 step and can also occur in the 2 step. So on that basis they are classified into E1 reaction and E2 reaction. E2 reaction are those type of elimination reaction that occur in the single step, and E1 reaction are those that occur in the 2 step. In most of the organic elimination reaction occur at least one hydrogen is lost in the double bond, that is being unsaturation of molecule. For example, in this reaction you may observe the dehydration of alcohol. Dehydration of alcohol means the removal of the H2O from the alcohol molecule. That is the over here you may observe when it undergo through the dehydration reaction in presence of sulfuric acid as a product, then the 2 more compound can be formed. The one of the major will be our alkene molecule. So more highly substituted alkene is usually formed as a result of the dehydration of alcohol. Oxidation reduction reaction. Oxidation reduction reaction are we know that those type of reaction that is going to cause the addition of oxygen or the hydrogen molecule. Oxidation reaction mainly occur in the different type of organic compound, like for example oxidation reaction can occur in the alcohol. Alcohol again are of different type. Some are primary alcohol, some are secondary, some are tertiary, depending on the valencies of carbon that are being satisfied. Are they depending on the whether the carbon is being substituted or bonded with one carbon or one other alkyl, 2 or 3 other carbon species. So when alcohol that is the primary alcohol undergo through the oxidation reaction, means oxygen is being added into those alcohol that is having the primary alcohol, then it will form aldehyde as a product. Again further, if that aldehyde is being oxidized, that can be converted into the carboxylic acid. In case of secondary alcohol, that where the carbon is again bonded with the 2 different other alkyl group, secondary alcohol undergo through the oxidation and they will form the ketone as a product. Tertiary alcohol cannot undergo through the oxidation reaction. Tertiary alcohol is basically CRR. Over here again it will be R. Clear? So a tertiary alcohol cannot undergo through the oxidation reaction. Thiol are those in which the sulfur atom is present. Whenever their oxidation occur, they can again form the different type of their radical reaction product. Aldehyde oxidation can result in the carboxylic acid. So this is the aldehyde, its oxidation will occur at this side and ultimately it will form the carboxylic acid. Reduction is basically the reverse of oxidation reaction. For example, if we are causing the reduction reaction, then it will again form the reverse product. For example, if ketone are going through the reduction, this is the ketone, when it undergo through the reduction, it will form the secondary alcohol, because secondary alcohol are generally going through the oxidation and they are forming the ketone. And when ketone undergo through the reduction, they can form the secondary alcohol. So over here are listed the main type of chemical reaction, their names that are occurring in the different type of organic compound. Like alkane mostly undergo through the combustion and the halogenation reaction. Among the alkene and alkyne, that are the unsaturated organic compound, mainly they undergo through the addition reaction. Addition we have discussed, that can be the hydrogenation, halogenation, hydrohalogenation, or it can be the hydration. They can also undergo through the polymerization reaction. The main type of chemical reaction that occurs into the aromatic compound are the substitution reaction, like the nitration, halogenation and sulfonation. Alcohol can mainly undergo through the elimination reaction, that is the dehydration of alcohol. They can also undergo through the oxidation that we have observed in case of primary alcohol. The aldehyde is a product of oxidation, secondary alcohol gives the ketone, and tertiary alcohol usually cannot undergo through the oxidation reaction. Thiol can undergo through the oxidation. Amines that can be primary, secondary, they can undergo through the acid-base reaction, that are the oxidation reduction reaction. Aldehyde and ketone. Aldehyde, for example, it can undergo through the addition reaction, due to which acetal and hemiacetal can be formed by the addition of alcohol molecule. Its reverse reaction will be the hydrolysis of that acetal with the acid. They can also undergo through the oxidation. For example, oxidation of aldehyde will give the carboxylic acid, and reduction reaction can occur into the ketone to give the secondary alcohol. Ketone mainly go through the reduction reaction to give the secondary alcohol. Carboxylic acid mainly undergo through the substitution reaction that we have already discussed in case of the esterification and amidation, depending on the type of organic reagent molecule that is being used in the reaction. Reverse reaction is basically the ester hydrolysis. The ester hydrolysis, ester which is formed by the substitution, and the carboxylic acid can again undergo through the hydrolysis, and again they will form the product. And again the amide hydrolysis, they can occur in the presence of acid or base. The carboxylic acid can also undergo through the acid-base reaction. The phosphoric acid are the phosphates. The phosphoric, that is the H3PO4. Its esterification with the alcohol can give the compounds, different products, the phosphates, phosphorylation. So this was all about the basics of the organic chemical reaction, the different type of the reagent molecule that are the electrophile and nucleophile. So in the next video lecture, I'll discuss about the main type of other organic chemical reaction, Deal-Alder, Bayer-Villiger, and different type of other chemical reaction.